When building some Lewis structures, you may have seen that in some cases there is a charge on a specific atom. We have not have described this charge slow enough probably, so it deserves to have its own video. So please, if you're watching this video and now you understand what the formal charge is, please go back to the Lewis structures to see how we incorporated the formal charge when building Lewis structures with charges. Alright, so the way we are going to assign formal charges on Lewis structures is assuming that in a bond the electrons are equally shared between atoms, regardless of their relative electronegativity. There are two ways to count electrons, and in Lewis structures typically we will use what we call the formal charge, which is what we're going to do now. In the next video we will talk about how to calculate the oxidation state, which is a different way to count electrons. In Lewis structures we will use the method of formal charge. So how can we calculate the formal charge? Let's see, in the case of the easiest one probably, nitrogen, how can we calculate the formal charge of the two atoms in nitrogen? Well, if you spend some time thinking about it, you will see that the Lewis structures of nitrogen is this one. So this means that if we consider that the electrons are equally shared, let's see how many electrons there are in each atom. In this case, there is 1, 2, 3, 4, and 5. This nitrogen has 5 electrons. This one, 1, 2, 3, 4, and 5. So you split the bond in two and equally distribute it for the two atoms sharing that bond. So in this case, since we know that nitrogen is a 2s2, 2p3, for a nitrogen to be neutral, it would need 5 electrons, and that's what it has. This means that in this case, both nitrogens are neutral. So there is no charge on each of the nitrogen, because in this case the way to count the charge is by splitting the bond in half. Now let's see something a little bit more interesting. In the case of nitrate, for example, nitrate will present some resonance, and notice that for everyone to follow the octet rule, you will have a certain amount of separation of charges, and I forgot the double bond here. So what is the formal charge in this oxygen? Oxygen should have a 2s2, 2p4. To be neutral, you will need 6 electrons. How many does it have? 1, 2, 3, 4, 5, 6. So this one is neutral. Nitrogen, however, as we said here, is a 2s2, 2p3. To be neutral, you will need 5 electrons around it. 1, 2, 3, and 4. So it's one missing 1 electron, therefore it'll be a positive formal charge. How about the other oxygens? Well, if oxygen needs 6 electrons, how many does it have? 1, 2, 3, 4, 5, 6, 7. That means it has an extra electron, and if you do the same here, it does have an extra electron. So there you go. Now we know why when we build and of course this has resonance, so please resonate this double bond in the 3 oxygens, but the distribution of charges will also resonate, not nitrogen, but now we know how to calculate these formal charges. Typically nitrogen is one of the most difficult elements to build Lewis structures because it has an odd number of electrons, and sometimes to follow the octet rule that's not very easy. In the case of NO2, nitrogen dioxide, you will see that I'm gonna come up with something that is not very satisfactory maybe, because if you count the number of valence electrons you will have an odd number. An odd number of electrons, that means there has to be 1 electron being unpaired. This is called a radical. A radical is a substance or a compound that has an unpaired electron. And I forgot here. So if you count first of all, it has to be neutral, right? So if you count the number of electrons corresponding to 2 oxygen and 1 nitrogen, you will see that you come up with an odd number. In this case, you have 1, 2, 3, 4, 5, 6. That means oxygen is neutral. You have for nitrogen 1, 2, 3, 4, 5. And again, it's neutral. 1, 2, 3, 4, 5, 6, and it's neutral too. So the fact that NO2 comes with a neutral charge, it means that you have to draw an unpaired electron, and NO2, like N2, has zero formal charge in all of the atoms.